So if I went 2 times 3 times 5, is that equal to 2 times 3 times 5? Is 6 times 5 equal to 2 times 15?
Yeah.
Looks good. Is 2 plus 3 plus 5 equal to 2 plus 3 plus 5? Yeah, that's going to be 5 plus 5 is 10. 2 plus 8 is 10. Looking good. Is 2 plus 3 times 5 equal to 2 plus 3 times 5? No. So this is what we call, and I won't abbreviate it, associative property of multiplication, associative, I won't abbreviate too much here, of addition. And then the other one I'm going to do is not this, because we see that doesn't work, but this does work. 2 times 3 plus 5 is equal to 2 times 3 plus what? 2 times 5. Yeah. This is the distributive property. So those you know about. Well, we can do that. Is 2 times 8 the same as 6 plus 10? It used to be. Yep. So we can still do these with sets. Okay, you can do this with AB. You can do the union thing. You can do the intersect thing. You can do the distributive thing with those. So those are properties that work. Wouldn't it be nice if we could actually prove it? Ooh. This is what you're going to be able to do before the end of the hour. I am not making this up. This is the proof of the, we're going to do a union intersect proof. And everybody go to this page. And what I want you to see is that there's a format to these. This proof isn't so important as how you learn how to set these up. You have this yellow part and you have this blue. Would you highlight those on your notes? So what essentially we're going to try to do is we're going to start with the yellow and prove the blue. We're going to start with the blue and prove the yellow. That's all the format is. So I'm going to start here. You see that X is an element of this yellow. And then we're going to use our sorcery and get this down to there in blue. That's the first half. And what we'll say is when we get the yellow equal to the blue, we'll say that this is a subset. Yellow is a subset of blue. Yellow is a subset of blue. Okay? Then in the second part, no big surprise. You're going to start with this blue, and what are you going to end up with? The yellow. Okay? And then when we're done with that, we're going to make this statement that the blue is a subset of the yellow. And when you can say yellow to blue, blue to yellow, at the end we can say that they're what? Equal is exactly right. And so that's our goal, is to say they're equal. Okay? But the way we do it is we get the first subset, and then we get the second subset in reverse. And you have to start with a first, end with the last, start with the last, end with the first. So let's see how they did it here. There's only one little tricky part. The rest is pretty systematic. We start with X is an element of A, union B intersects C. So X is an element of A, union here is OR. So when you see U, you use OR. X is an element of B intersects C. Oh, that's the accepted terminology for union. What is it for intersect? And, yeah. So Or means, well, think of it this way. If I'm going to pick at random a guy or a gal, okay, guy or a gal, you'd want to know how many guys there are and how many gals there are, right? If we're going to look at guys, the people wearing yellow shirts, people wearing green shirts, like Gabby, and there could be someone with yellow and green on. So you look at having both or one or the other. All right, so then this one, X is the element of A, then X is the element of A, union B. This is the tricky step. Would you underline this one? This is kind of an obvious step that if X is an element of A, could I union with anything? Sounds bad. Yeah. You could, if you're looking at X being an element of A, if X is a part of A, X is a part of A plus turtles and A plus salamanders, right? So you can union this with B and C. Doesn't do anything. But again, we're trying to get down to here. So now when we do that, now we can change this AND back into a intersection. And now we have X as an element of A union B intersect A union C. Now this one is the second part. If X is an element of the B intersect C, then X is an element of B and X is an element of C. We can union that with A again, just turtles this time. And so both of them are union with turtles. And then you're going to be able to say A union B intersect A union C. So therefore, this is a subset of this. And that's what I'm saying here. A union B intersect C is a subset of that. And I just did the same thing in reverse here. I started with the second, broke it down, unioned with things, and it just all worked out to give you the second one. And then if I get this guy and this guy, you're going to get those equal. The example doesn't work super well unless you do it. So we're going to do that next. Let's take this De Morgan's law. De Morgan's law are two figures here. The first one is A union B complement. So A union B complement is this. Okay? And then A intersect B is this guy. The complement, oh, excuse me, I'm looking at the second one. Not A is out here, not B is out here. The intersection of those is this blue again. I think for this one, A intersect B complement, A intersect B complement is going to be all of these, which is not A union not B. Kind of weird. And of course, we're going to prove these. We're going to prove the first one right now. We're going to start with A union B complement. So X is an element of A union B complement, and I want to prove it down to that. So then if the complement means not, so if X is an element of A union B complement, then the X is not an element of A union B. And here's the only tricky part. Would you write yourself a note? Everybody on this one? Write yourself a little note. This union here, make sure that when you do the opposite, union becomes an intersection when you do the opposite. That complement of A, which is no big deal, complement of B, you're going to have to complement the union, which makes it an intersection. And that's how you get the A complement intersect B. So this establishes that A union B complement is a subset. Then do the same thing. Do the same thing. You start with this guy, and you're going to end with, actually I'm going to reverse these. I'm going to end with this one, and you're going to start with this one. And then once you go through that again, watch that and oppositing to a union, and then you're going to get this being a subset again, and then you can say they're equal. And it'll get better. It'll get better. Here's some laws that we've mentioned so far. It's an overview. Just read over these, use them, and then we're going to launch right into this group problem. See how far we can get with this. For all sets A and B, prove that A union B union C equals A union B union C. We're going to prove the associative property for union. So we're going to start with this part. Let X be A union B union C. So then X is an element of A union B, which is that X is an element of B, or X is an element of A, or X is an element of what for union? Could be A, or it could be what? B. B, right? Could be if for A union B. Or it could be X is an element of C. So this part, I just broke this part down into that. This is still the same. Now I can say X is an element. Remember, we want to get it into this form. We can say X is an element of what? Huh? A, yep. Or X is an element of what? To make it look like this. If it's X element of B or X element of C, could you say X is an element of B union C? So then, now we can say X is an element of A. Instead of or, we can put union B union C. So, if X is an element of A union B union C, then what we can do is we can say that then A union B union C is a subset of A union B union C. Then you finish this by doing the second half, and the assignment will have 2 problems at the end. I will check them, 3 and 3.